If you didn't catch the introduction, my name is Patrick Mooney. I'm the field engineer for CAMCO, and welcome to the CAMCO version 13 webinar rollout. We're here today to tell you about GibbsCAM version 13 and all of the benefits that you have in it. We're going to talk a little bit about some version 12 features. I'm doing a sound check here. I want to make sure that everybody can hear me. Mr. Ellers, can you hear me up there? I heard a faint knocking noise. Everything sounds good. So in version 13, we went and worked on the interface as far as functionality was concerned. When we rolled out version 12, we knew that we needed to update our interface from where it was 30 years ago to where our software engineers told us it needed to be today. And one of the first things you noticed is that we placed the ribbon, instead of on the side of the screen, we placed the ribbon across the top of the screen. It was there for convenience and speed, and for the simple fact that we see stereo vision from left to right simply because our eyes are fixed horizontally in our head, and we have monovision vertically, so we can scan faster across the buttons from left to right than we can from top to bottom. So in version 12, we wanted to clean up the interface and bring it up to 21st century standards. And in version 13, we added many functional items that you will no doubt be able to use. Let's look at this first item. One of the things that we have in version 13 is approach and retract. We now have the ability to draw a simple feature that we can guide a tool into a confined area. Let's watch this toolpath run. And you can see the outside is pretty simple. We don't have a lot of restrictions there. But when we get into this middle piece, we want to guide the tool in there because we might have some conflicts with the back of the tool. And it's a little bit easier if we use a guide curve to get the tool in and out. Now the guide curve's coming up, and I'll play this again for you, but the tool is going to follow this guide curve into this area. We simply draw a 2D shape and tell GibbsCAM to use that shape to guide the tool in and out of that area. Let me open my tools and CAM list, and we'll go right to Op 5. We'll rewind, and we'll play Op 5 by itself. I'll run it in single block. There's a tool change. And you can see that that tool guided itself right into that area. Of course, we didn't remove the material before and after that, but you can use any guide curve. And as you can see in the next file, we'll go to the next file, Advanced Approach and Retract. We'll do it with an ID. Now the ID doesn't present any more challenges. It actually makes things quite a bit easier. On the guide curve entry and exit, we may choose to use the same curve for entry and exit, or we can use one curve for entry and another curve for exit. Let's watch it run, and then we'll show you how we did it. We'll let this one run a little bit slower, and you'll see the tool follows the guide curve into the area safely. And this is a fairly confined area where the back of the tool might have some difficulty getting in. We'll speed this tool path up. We're doing a plunge turn type tool path with a dew grip, heli grip, Manchester, or any one of a number of tools that is capable of doing this. And as soon as this tool path is done, we're going to slow down, and we're going to look at the entry and exit for the top of the groove using the same tool, but a feature in GibbsCAM that allows us to flip the tool over to another orientation on certain machines like the Morisekis, the Mazak Multi-Series, and the Akuma Integrex. Not only did we do that, but we can turn the head to a different angle and still rough with it at that angle. GibbsCAM recognizes the tool angle and makes sure that the shank doesn't hit. We get another tool angle to get the right-hand side of the groove here. Now let's look at how we accomplish that inside of the operation. First, we create an operation just normally. Forward, back and forth, turn, speed, feed, depth of cut, material. And then when we're done, we right click, and under operation data, you'll see that there's a new button that says advanced approach and retract. And we can specify an approach curve, and we can specify a separate retract curve, or we can simply say retract as reversed approach. And you can draw any 2D shape to guide the tool in and out of that area. So as you can see, you simply right click, operation data, and there's a new box here for advanced approach and retract. One of the new great features inside of GibbsCAM 13 that allows us to get in and out of very confined spaces very quickly. We'll go to the next file, and another new functionality that we have in GibbsCAM 13 is broaching. All of a sudden, everybody wants to broach in every machine that they have. Some machines are capable of broaching, some machines are not. But if you have a machine that is capable of broaching, we have a tool path for you in GibbsCAM 13. We can use single point broach tools, form broach tools, and multiple point broach tools. Now, this not only covers linear broaching, but it also covers rotary broaching. If you've ever seen a rotary broaching tool, some people call it a wobble tool. This type of tool has actually been around for 40, 50, maybe 60 years, but it has come of age in the CNC world where we can actually do certain things with it. And as you can see here, we have a travel limit exceeded. And one of the things about machine sim is that it tells us if our tool holders are positioned correctly, or if our y-axis or x-axis has enough travel to go to the other side of the machine. And in broaching, I want you to look at the broaching tool path. We'll open tools in CAM, and let's look at the tools. On the tool list, we have milling tools, we have turning tools, and now we also have rotary tools. L stands for linear, R stands for rotary. Linear hex, linear key, linear chamfer, linear combination, 6 load, 2D form, 3D form. So if you have a broaching tool that you made or that you had custom made, you can simply bring it in as a 3D form tool or a 2D drawing and make an actual broach tool out of it and use it for broaching. Now, in broaching, we can choose to either index the chuck or we can index the broaching tool, depending on which type of machine you have. Some machines have the ability to do both. Some machines have the ability to do one, which is to adjust only the spindle itself. And of course, with broaching, if you're going to do any complex broaching, as in stepping over to widen out a key, you will need a y-axis. Let's look again at the broaching tool dialog menu. And as you can see, we have the end view and side view. And we get to determine the distance across flats or distance across corners, and also if it has a corner radius or not. Once it has a corner radius, we can simply select a piece of geometry, and we have numerous types of geometry that we use for broaching. Number one, we can use a reference hole where we simply click on a circle and tell it what the hole diameter is, or use circle diameter where available. That way we can use multiple holes and still do the same broaching operation. Distance across flats, how much stock we want to leave, clearance amount, first step depth. And as you can see, the menus are graphic and descriptive. Whenever you click on a new data field, the graphic changes and tells you exactly which dimension you are looking at. Final step, desired step over, and we all know the rules on broaching from our machinist days, and entry feed, contour feed rate, and exit feed rate. Another thing that we have in broaching is that when we are working on a hole or a broach feature that has a blind bottom, we have a problem that we've always had when we used our broaching attachments in the milling machines, is that the chips tend to pack up and stack in the bottom of the hole. In GibbsCAM, we have created a unique solution to that, simply called ramp out. When the broach goes to the bottom of a blind feature, It gets to the bottom, it simply pulls out horizontally, snaps the chip off, and then you're using either high pressure coolant or air to blow those chips out of the bottom of the hole, which allows us to continue broaching to the bottom of that blind feature using this one click button and redo and ramp out, and it will snap each chip off as it makes it on the way down. So we have a number of broaching toolpaths here, and as you can see on the rotate tab, you still have the functionality of rotating this here on multiple orientations with the spindle, or here with multiple orientations on the turret tool. So you can control it either way depending on the capability of your machine. Let's have a look at this broaching toolpath one more time. Let's go through a couple of them on this big Doosan Puma 4100M. So linear broaching. Let's go look at the next example of broaching. Let's look at rotary broaching. Now, rotary broaching involves using a special tool, and we'll look at the rotary broaching tool. It looks very much like any other tool, except when you look at it in your shop, it has an eccentric bearing either inside on the hole or either outside on the broach itself. And the point of the broach is ground to a concave condition, and it actually broaches while the tool and the part are moving. It's called wobble broaching or rotary broaching if you've ever seen it. Now on GibbsCAM, it simply looks like a contour. Here we specify rotary broaching. We have an entry feed rate, we have a contour feed rate, and we have an exit feed rate, a start point and an end point, spindle forward, entry RPM, broaching RPM. So you may have a different entry RPM and a different entry feed rate depending on what the manufacturer would like for you to do. We'll go to Machine Sim and let's slowly watch one of these rotary broaches. Of course, you don't get the animation of the actual broach doing the wobbling, but as you can see here, we have a number of form broaches, internal and external, that simply cut that shape on the end of your part. And for those of you who are making medical or aerospace parts, you are very familiar with making certain types of fasteners for them, maybe a 100-degree countersink with a certain type of Torx, or the other Torx type screw that has a hole in the middle of it. Those are all examples of wobble or rotary broaching. And again, to us, it simply looks like a tool path going in and out. The feed rates are very slow because it's actually peeling the metal as it goes down through the hole. So we have linear broaching and we have rotary broaching. The next feature that we would like to look at inside of GibbsCAM 13 is the ability to do eccentric and elliptical turning. Let's look at this camshaft first. And of course, you have to have a machine that is capable of doing this. And by the list of attendees, I can see that a number of you do have that capability. This happens to be a Moriseki NT4250, which is now today called the NT4300, and they dropped the DCG off of it. So let's zoom in on this tool path. And as you can see, there's quite a bit going on when you're doing eccentric turning. The tool not only has to follow the eccentric, but the y-axis has to maintain the rake angle of the tool. So here we're going to use our little button here that says show position to see exactly what's going on. Which axes are moving while this action is turning? Well, obviously the c-axis is moving. The x-axis is moving to follow the eccentric, and the y-axis is moving to maintain the center line with the surface. So here we have 4 axes moving at one time. I'll speed this up so we can get through and look how we transition over from one to the other. Eccentric and elliptical turning. So let's look at the tools. The tools don't look any different than any tool that we have. Let's look at the operations. The operation looks pretty much like everything that we already have. If we go here to the process list, you can see that We have elliptical contour, but here we did a plane contour with geometry. And the interesting thing about elliptical and eccentric turning is that we can either use geometry, or we can use a solid model, or we can use a combination of the both. So let's go to the next example to see on this particular part how we use a combination of geometry and solid model. Here we have a solid model. I'll turn the geometry off just for convenience. And the solid model was built to display the full capabilities of eccentric, elliptical, and concentric turning. This particular part was made so that it has an eccentric circle. And then we have the next elliptical part, which starts as a circle and ends as a square. And then the next section, elliptical section, which starts as a square and ends as a circle. We'll look at op 1. And as you can see on op 1, we simply selected a contour and we selected the geometry like we normally do with our machining markers. Let's look at op 1. Watch it run on this part, on this particular machine. Let's have the door open. And we'll run this fairly slowly at first. And as you can see, there's a lot going on. I'm going to speed this up as we go through this toolpath so that you can see how it transitions and how the motion changes. We're staying on center line right now. Let's see how the motion changes when we start to transition from from round to square. So now we're into the round to square part, and you'll see as we start to move up this elliptical surface, the y-axis now starts to get more engaged in keeping the tool on the center line. And by the time it gets towards the square section, it has fully transferred and morphed from round to square. The y-axis is getting more fully engaged in keeping the rake angle of the tool to a term that we call face normal. We're going to move up the surface a little faster and watch it transition again from square. A lot of y-axis movement now. We're going to watch it now transition from square to round to finally concentric. So we can do all three types of toolpath on the same part. And yes, you can see we're going from square to round, so I'll speed this up a little bit. By the way, it's very exciting to watch this in a simulation. It's even more exciting to watch this on a machine, to see the machine engaged in doing what it can do. Now we're starting to get more towards the round, and the y-axis is getting less and less engaged in moving off center. You can see the numbers are getting smaller and smaller and smaller in y-axis until finally we reach a diameter, and then we'll turn right into the chuck jaws. Now we've transitioned fully to round. The y-axis is now settled down. We're only about 20 thousandths, 11 thousandths, 20 thousandths, and we're almost there to a fully concentric tool path. And when the y gets to 0, we're on a concentric tool path, and off we go. So eccentric, elliptical, turning. We can do it all on one part with one tool path based on simply all of this geometry. We change the start point, the end point. Let's say start Z is now 0.1 instead of -5 inches, and end Z is -17 inches, and press redo. And now the whole part is done. You can see the task manager down here is processing the information. The information is complete, and we have performed an eccentric, an elliptical, an elliptical, and a concentric operation in one complete operation inside of GibbsCAM. Let's move on to, we've done eccentric. Let's look at the Wankel, which is kind of ironic because, as we all know, or as many of us know, the Wankel engine is dead. There are only a few left out there, and I don't think there are any in production right now. Let's look at the large amount of swing that the y-axis has to maintain to get the Wankel part turning correctly. Now, the Wankel engine may be dead, but the Wankel principle still lives, and they are now designing an inverse Wankel engine, where instead of the piston turning, the cylinder rotates around a stationary piston. But here we wanted you to see this particular tool cutting a Wankel rotary style piston. Now, something else that we want you to look at here is that in this particular machine, you'll notice that lathes have changed quite a bit in the last 15 years to 20 years. Instead of a lathe, a live tool lathe with a little bit of y-axis, they have transitioned fully into a milling machine welded to a lathe, which gives us a tremendous more amount of capability and the ability to take any turning tool that we have and cut with it at any angle. Let's look at this from the front view. And you can see that we have the tool tilted at an angle. We don't know what the angle is. So let's open the operation and go to the rotate tab. This tool is at a holder angle of 47.5. Well, let's make it 35 degrees and simply press redo. And as the task manager processes this information, we will now cut this Wankel style piston at a new angle of 35 degrees. And if your machine has TCPC and dynamic work offsets, then this is a non-issue for you. There's no more action needed other than to repost the code and put it into the machine, and you can now cut with this tool at a new angle. Now, this will become important to us later when we talk this morning about volume mill turning. So let's take a break from turning for just a moment, and let's go look at one of the exciting enhancements of the GibbsCAM 5-axis or multi-axis module, which I like to call it. And if we right-click here in the process list, we look at the 5-axis module, and we're going to put this tool on it. The 5-axis module is our new go-to multi-axis module because what it does is it does 3-axis surfacing, it does 4-axis surfacing, it does 5-axis surfacing, it does 4-axis rotary mill, and it does 5-axis rotary mill. And in this case, in GibbsCAM version 13, we have a new toolpath in GibbsCAM version 13 for this under general surface paths based on deburring. Let me let you see this part run first. And this is going to be on a DMG DMU50, which is one of the most popular milling machines out there right now, the DMU50 and the Haas UMC 750. And what we simply do, and it's going to take us a couple of times to look through this, is that we want to deburr the part. We're not talking about chamfering the part. We're talking about simply knocking the edge off of this part with a round lollipop tool. Standard round lollipop tool. It can be a grinding wheel. It could be a carbide burr. It could be a purpose-built, even a resinoid bonded rubber type tool that you would use for deburring, which allows you to use a little bit more tool pressure and give you a little bit better finish. But this deburring package is nearly fully automatic. Basically, all you have to do is point at the part and say, okay, machine this part. So let's look at how we process this. Remember, solid models are made up of faces and edges. And as you can see here, I have face selection off and edge selection on. I selected all of the faces of the part simply by clicking V part. And we said part surfaces were all of these. And then we elected, instead of to use auto detect, we selected user defined edges because I can select one edge, press OK, and redo, and it will just, as you can see, the process manager, it will just deburr that one surface. Let's see if we select auto detect and see if it gets all of the edges, which it very well should, if we have selected them or not. Process time, clicking away, 7%, and that will accelerate very quickly in just a moment. It's also looking for rotary solutions to the machine, because this machine can only go a certain distance in the B plus direction, and in the B minus direction, it can go 110 degrees. And here we are at 97%, 97%, and we're completed, and there we are, and we have deburred the part again. So if we go back and look at this part on the deburr, we can see that the machine is always looking for a rotary solution in what it can do and what it can't do with the B axis. This machine also has in it a feature called clearance volumes. And you'll see when the tool moves from one set of surfaces to the other, it stays within a stock cube that we define on the clearance volumes tab. And we'll do another session on clearance volumes, and there's a clearance volume move right there. It keeps the tool near the part rather than retracting all the way home, while all of the rotary axes and the tool are approaching the part at the same time. Let's have another look at that. Let me speed it up just a little bit, and we'll watch clearance volumes work on this rotary deburring part. And again, this works on very, very complex 5-axis surfaces. And for the most part, it's automatic. We simply click the surfaces, we click the edges, or not click the edges. We just had the edges visible. It found the edges automatically. And by the way, while it is doing its deburring, let's open this and let's look at here. We have tool parameter, edge shape, constant width. We click here, and as you can see, the graphic says this is what we want for a deburr. Well, we can go all the way down to 1,000s or a half a thousandths or 5,000ths. And under tool axis control, we also want to make sure that the holder clearance stays far enough away from the part not to hit it. We told the shaft to stay 10,000ths away from the part, and that it does, because GibbsCAM analyzes the shaft here on the tool and make sure that it stays within 10,000ths away from the part so we don't crash it. So here we go, deburring and clearance volumes, movements from one area to the other. It moves the part and the tool safely so that we don't crash into each other, while at the same time maintaining the rotary solution that this machine is capable of. It can go -5 and +110, and GibbsCAM will keep the machine inside of that envelope. This is a very, very exciting toolpath to me inside of GibbsCAM, as I've seen a number of customers use it with the lollipop tools of different shapes and sizes. We're going to turn off the process manager here, and let's go to another concentric turning. We have a cam here, an eccentric cam. I'm going to turn off edge and face selection, bring up the machine sim, and we have a wheel here that has a cam on the outside of it. The wheel is simply chucked up inside. And as you can see, this is an eccentric cam. So if you're in the cam business, or if you have eccentric shaped parts, and it doesn't have to be round. Remember, it can be square or triangular or octagonal. This toolpath will be able to handle it when you bring it inside of GibbsCAM. And this is just doing a normal contour with geometry brought straight out of the profiler. We simply fired up the profiler and I said, I want to machine this. GibbsCAM recognizes it as an offset surface or an eccentric surface. We can change the angle of the tool and turn this surface inside of GibbsCAM. Let's move on and let's see what else we have. Let's go back to another milling example, and let's talk about face milling. Anybody can put a toolpath on a part, but the fact that we want to put a good toolpath on the part in that when we're face milling, let's look at this face milling toolpath, and all of the entries are straight in. And let's look at first real quick, let's look at the step over. I got 1.3786, which is 70% of the cutter. We know as machinists that face milling is done 70% climb, so that we get a good entry angle on the insert. If we go to a 50% entry angle on the insert is slamming into the workpiece because it's exactly perpendicular to the work edge, and insert failure is premature because of the slamming of the edge of the insert into the part. So we want to ease the insert into the part by using a 70% climb. Well, that's fine once the tool is fully engaged, but if we single block through this, and in this area right here, where we approach the part, just as the tool gets engaged here on the right, we still have a chip thickness problem. We always want chips to be thick to thin, and we're speaking machinist language here. We always want the chips to be thick to thin, but on the entry, we have a thick chip on entry and we have a thick chip on exit, which gives us a terrible finish right here at the beginning of the face milling process. We get a terrible noise and we still get a little bit of premature insert wear. So there is a simple solution to this, and it is called roll-in entry. It's a one-button solution inside of GibbsCAM. We simply select roll-in entry, click redo, and GibbsCAM now rolls the entry in, and this is a clockwise roll in. Clockwise roll in also gives us a progressive 70% climb entry, and we'll slow this down so we can see this tool enter the part. Let's go over here on the end where we can see it a little bit better. And you can see the roll in entry as it comes into the part. So for the total continuation of each stroke, we have a gradual 70% entry that gives us a better part finish, gives us better insert life, and it keeps us from having to slow down our feed rate with a utility marker while the cutter is entering the face milling cut. So it's not just about putting a tool path on a part, it's about putting a good tool path on a part. It's about increasing part quality, and it's about increasing tool life. So this was a single click solution inside of GibbsCAM called roll-in entry. And you can go onto YouTube and search for Sandvik tips film roll-in entry, and Kevin Lorch will explain to you how that works as well. You'll be able to see it on a video that he did a really nice graphic on. Now, other enhancements inside of GibbsCAM. Let's look at chip break turning. For those of us who turn very difficult materials, such as stainless steels, we know that they can have a propensity for chip breaking to be very, very difficult. They want to make birds' nests. So the first thing we do as a machinist is we decrease our depth of cut and we increase our feed rate. But by doing that, we lose production on the part because we generally cannot increase the feed rate double what we did that we changed the depth of cut. So the next thing we would do is we would use a different style chip breaker. So we have to stop and wait and find and test a chip breaker. And the third thing that we would do as machinists would be to reduce the corner radius on the tip of the insert. Those are three things that will help us break the chip. But we have a part in the machine right now, and it's got to be cut, and we've got to do something about it now. So in GibbsCAM, we go to chip break, we click pull off, we set the pull off distance in Z, we set dwell onto how many revs do we want to dwell at the pull off distance, and we set chip length. Now let's talk about chip length for just a second. Before we do that, let me show you how it works. That way you get an idea of what is actually going on inside of the machine during the chip break cycle. Let's zoom in really close on this. So yes, we are cutting, we're pulling back at an angle so that we don't drag the tool across the workpiece, and we're actually forcing the chip to break. And in many cases, this saves us a lot of time, because the time that you spent opening the door and pulling the bird's nest off the turret, and then the bird's nest gets wrapped around the part, wrapped around the chuck, wipes out your probe in your turret, and you've got a terrible mess on your hands. We're doing everything that we can do to help you break that chip, and also do it at a fast enough rate to where you don't lose production. And the offset is that you don't have to keep opening the door and get rid of the bird's nest, So let's look at what we did to make that happen. Pull off, dwell, and chip length. Now let's talk about chip length. Chip length is the actual radial length of the chip, which means that if I set it to 10 inches, it's going to make a 10-inch chip long, and then it's going to stop, break it, do the pull off, dwell, and then approach the part again and continue cutting. Now, if you are cutting on a tapered surface, keep in mind that chip length is going to be consistent, just like constant spindle speed is for you on a diameter. The chip length will maintain a 10-inch chip length no matter what diameter you're on. So let's speed this up a little bit and watch the chip break toolpath in GibbsCAM. And we've saved a lot of time and a lot of process security. We do know that bird's nests give us terrible process security. And if you have the wrong chip conveyor, they also give your chip breaker, your chip conveyor, a bit of a time, because the chip conveyor may get hung up. It may have to stop, reverse itself, because the bird's nests tend to get hung. And yes, we can do a no drag tool path on the chip breaker cycle. And now we have a finish pass, no drag on the outside of the part. So the chip breaker cycle is very, very simple, and it is a 2-click 3-data field enhancement to GibbsCAM 13. So let's go look and see what we have. Let's look at volume turn while we're here and talking about improving our turning. We all know what volume mill did for our milling. Volume mill allowed us, when we're milling with end mills in confined spaces, volume mill allowed us to increase our production by a factor of 2, and to decrease our tool life by a minimum factor of 4. And many times we can go to tool life greater than 7 to 10 times. Well, now we have volume turn. And keep in mind that high-speed machining started a long time ago with trochoidal machining and our simple chip thinning formula, while we're running an end mill down the side of a part using only a very small fraction of the end mill. That is the essence of high-speed machining. But only in GibbsCAM do you find that volume mill is a licensed part of GibbsCAM. And here we have volume turn. And as you can see, if you know anything about volume mill, you'll see that the tool path looks like a bowl of spaghetti, just like it looks on the milling machine. But it allows us to increase our surface feet per minute because of the short contact length with the tool, and to drastically increase our feed rate because of the small contact area of the tool itself. So let's look at a volume turn tool path and see what it looks like on a confined space on this DCG. And as you can see here, we have a conflict with the spindle and the chuck. We want to keep that part as close to the chuck as possible while doing our volume mill turning. And we always want to do that during every tooling operation, every turning operation, every milling operation, every drilling operation. When we are cutting with the side of the tool, we have to maintain our engineering rule of 3 times the diameter. So here we have a conflict between the spindle and the chuck. We could either put a longer tool holder in here, or we could simply, as we know about the Integrex, the Multus, and the DCG series, we can go to the rotate tab and we can tilt the tool to let's say 75 degrees, press redo. There's our tool path. And if you have a machine with tracking on it, TCP tracking on it, you can see that we have eliminated the conflict between the spindle. We have eliminated the conflict between the spindle and the chuck for the tool while still maintaining our volume mill cutting. If we turn the tool too far over, GibbsCAM recognizes the shank and it will leave material down here in the corner. So volume mill turning combined with the capability of our new B-axis milling machine lathes, and it's a milling machine and a lathe welded together, allows us to cut, number one, tough materials or soft materials, but we can cut more efficiently inside of confined areas with round inserts. And again, we can double our production and increase our tool life. Volume turn. Let's go and look at our demo here for a Swiss machine. And what we're talking about here is not actually Swiss turning, but we have a Swiss machine up here. And a Swiss machine is what we call a multi-flow machine. We have some Swiss machines that have 12, 13, 14 axes, and they might have a laser built into them, which brings a whole new set of challenges. But here we are looking at a simple 3-flow machine, the left flow, the right flow, and the subspindle flow. In GibbsCAM, we have a new feature in the posting area called our internal post editor. And in our internal post editor, as you can see here, it is now color coded, and we can go in and change the color of each type of information that we have in here. And we can change the colors. We can also have an operation list here on the right-hand side of the screen that allows us to go immediately to the beginning of an operation or to the end of an operation. But notice that here, I only see flow 1. And there's weight codes in here for flow 2 and flow 3. So we're looking for MS1, MS11. So where are our other flows? They're right here on these other tabs. This is flow 1, which is tool group 1. Flow 2, which is tool group 2, and it has its weight codes in here as well. And then flow 3, which is a work group flow, which is the sub spindle. And the work group flow has its drop off into the parts catcher. So here we wanted to show you a little bit about the code editor inside of GibbsCAM that simply lets us look and examine things before we send them out to the machine. Does our code look correct? We have color coded. We can change the background color. There are a number of things that you can do inside of the code editor, including your G-code text styling, your colors, your background color. I personally like a black background color in my code editor. It makes a little bit easier on my eyes, and it makes the code stand out a little bit more. We may have to brighten up some of the other pieces, but the code editor is now here in GibbsCAM, and let me show you how to access that. On the File menu, under Preferences, G-code editor settings, either no G-code editor, the internal editor, which is our own multi-flow editor, or you can select a custom application if you happen to want to use Notepad or CAMCO or Predator or any other type of G-code editor. So let's go back to one of our other files that we had open earlier, and let's talk about the Operation Manager, because the Operation Manager has some new functionality in GibbsCAM 13. At first, when you open the Operation Manager, it looks like this. It has all of the material in it, and there's a lot of stuff in there. But you can customize the Op Manager now to show exactly what information you want. For instance, right now, if we click here, we now have a new button, a little picture of a stopwatch that calculates the cut time. And here is the cut time. And somewhere in this line of information is the cut time. But let's you and I modify the op manager. We're going to customize headers. We're going to remove everything from here. And we are going to start with the very first thing we want to do is cut time. So we're going to click cut time and press add. The next thing that we might want to do is op type add. I would want to add at this particular time our RPM so that I can see what's going on, my entry feed, and my contour feed. And let's add one more piece of information on here. Let's add the tool number, which is TL right here. Let's add the tool number, press OK, and look how much the op manager has been cleaned up. Now we simply recalculate the cut time, and we can see that the op has cut time, op type, and we can spread these out a little bit. Op type is milling, speed, RPM, entry feed, contour feed. What was this part? This was a deburring part. So let's go to another part that has a little bit more milling in it. And where did I have a little bit more milling? We'll just go to the face milling op. It only has one op. And let's see if we have anything in here. Nope, I think that's not a good example. Let's go to advanced approach and retract. And now we'll go to op manager where we have 3 ops and we want to know the cut time between those ops. Let's fix that by customizing, remove all, and let's just add cut time because that's what we're concerned with today. Let's look at cut time is unknown, and now cut time is known. Now, when you get the op manager customized to the type of information that you want to show, you may then sort that information simply by clicking on one of the headers. We have cut time ascending, we have cut time descending, and we as machinists, we're generally going to use descending because when we go to optimize a program, we want to look at the longest op first and do whatever we can to make that op work faster. So we look here at max RPM. Let's change that to 3,500. Let's change the surface feet per minute to 1,350 because I have a new insert. The current cut time is 5:35 and 3:16 on op 1. Let's redo that op. The cut time is unknown until we press the button. Now the cut time has gone from 3 minutes 16 to 2 minutes 8, and we're down to 4 minutes 27. So the op manager is a tremendous tool that we can use to analyze our program and to optimize the program by using cut time in a descending mode. We go after the longest ops first, and then when we're done, we go back and sort by op time ascending, or you can do op time descending, but we generally do op time ascending. Let's see what else we have in our bag of tricks. We have gone through all of the part files that we needed to go through. And let's see, Mr. Bart, would you like to open the floor to questions, or what would you like to do at this time?
Hey, Patrick, can you hear me?
I can hear you, Mr. Bart.
All right, great. Yeah, let's go ahead and open this up to a question session. Thanks for everybody for staying in here and watching this video, or watching the webinar. But now we'd like to open up the floor to anybody that wants to ask any questions. And to ask a question, you can simply type in a question. You should have a questions area panel in which you can submit a question, and we'll go ahead and answer those questions as they come in. Hey, Patrick, I'll start with one.
Yes,
one of the new features in 13 was the op stacking. Is the op stacking an automatically set, or is that a user preference setting?
It's automatic. And let me do a quick op stack here. I'm going to make a new file, and let's see. We're just going to call it op stack engrave. So I'm going to make a brand new file. Save changes, no. We're going to do something real quick and dirty here. Document control. We're going to slip right up to 3-axis vertical mill and set our stock size to, yeah, it looks good. We'll go to 1 viewport. And by the way, there are multiple viewports in GibbsCAM if you didn't know it. To get to the multiple viewport manager, you simply click this button. Click on, and you can set different viewports, different custom viewports. Once you get there, you may modify it by clicking here and setting 3 windows, 2 windows, 1 window. And there are a number of things that you can do inside of multiple viewports if you have a very large monitor like I do. So let's throw some engraving down on this part real quick and show you what op stacking looks like. It's scanning through my Windows font, and we're going to grab the Moorpark font. The Moorpark font is a font that we created at GibbsCAM. Did I spell GibbsCAM right? We're going to make the font height 1.0 inches tall, centered here, and do it. And now we have some geometry. We created the GibbsCAM Moorpark font to emulate the AutoCAD monotext font. It is what we call a single strike font, very, very simple to engrave with. I'll create an engraving tool, simply going to use a countersink with a 0 point and this nice big fat tool holder. So we'll create an operation and we're going to make it a contour starting at 0, and we're going to go to minus 20 thousandths. This is going to be a nice fat one. Retracts and depth first are on. We don't want any lead ins or lead outs because that would make a terrible mess for us on engraving. Engraving is as simple as selecting the engraving geometry, and we go to Sim, and I want to say no machine, because all I want to see is the stock. So now we have a piece of stock and we have a tool, and let's watch the engraving happen. Let's set point of view locked apart. And as you can see, we're cutting our engraving into the part right now. So the point is not engraving, but the point here is op stacking. In GibbsCAM version 13, if you have a lot of engraving, you're going to have a lot of ops. But what we can do to clean up the operation list is we have several buttons here now at the top of the operation list. And the first button is individual op mode, where you get to see every op. Every stroke is an operation here. And if we want to compact that into one op, we can simply click op stack. And we have cleaned up the operation list in more than one way. Number one, we compressed all 11 of those ops into one op, which means that we can see more items here. But as you can see, the numbering scheme stays just like it should. You can see that ops 1 through 11, if you wave your mouse over it, are all compacted right here in this one op. And when we double click on it, they all come back open. We make a change, we press redo, and the op closes again and it goes away. And you can see the next available op tile is op number 12. So op stacking is always available to you, and you simply click this button. You may also create your own custom op stack. You could select 1, 3, 5, 7, and 9 and stack it, and it would go into a stack mode. And as you can see here on the icon, when you have stacking turned on, it appears as though it is a stack of, looks like sheets of paper to me. Those ops are stacked on top of each other. Mr. Ehlers, what is the next question that you have?
Well, let's see. We have a few questions asking about supporting the new features and the ramifications on the post processor. So I can handle that one real quick, Patrick. So a few people have asked, with all the new machining functionality in the software, and there's quite a bit added in this version, what do we need to have the post upgrade? And the answer to that is kind of a mixed bag. So for example, to support the advanced approach and retract, no, there is no post upgrade needed. But there are other ones that do need an upgrade, such as to support the broaching would need a post upgrade. Doing the advanced face milling would not need a post processor upgrade. So the best way to find out what features that you would like to support, and if you need a post upgrade, it's just to contact CAMCO. Contact us. We can look at your individual post and what you want to do, and if we'll be able to support it. Okay.
Yes.
Okay.
Next
Another question. Yeah, another question for you, Patrick, is the deburring available in the multi-axis module only?
That is correct. The deburring is a function of the multi-axis module. Now, for those of you who have been using GibbsCAM for a long time, the deburring plugin is still in GibbsCAM under geometry. I think it's geometry. There's a deburring plugin somewhere here. I've used it a number of times before with very good success. So there is a deburring plugin somewhere here inside of, and I don't find it. So if I click here under search, if I click deburring, it should show up under, I don't see that it's come up. So maybe we don't have that functionality anymore. I don't see it in here, but the 5-axis module does have the deburring package as part of its toolpath. So yes, this is part of the multi-axis module.
Well, and I would expand on that, Patrick, a little bit to say that the multi-axis package, as you noted, can support 3, 4, and 5 axis. And a lot of people are starting to realize that you can use the machining strategies in the multi-axis package for non-5-axis parts or non-5-axis features. And there's a lot of advantages to that. So for example, better tool life, better machining strategies, even for non-4 or 5-axis parts or features. So, and deburring is just one of those advantages.
Yes, exactly.
Okay, here's another one that I'll field, Patrick. Will a recording of the webinar be available? Short answer is yes, this will be made available. And as one of the email follow-ups to this webinar that you'll be getting, one of them will have a link in it to where you can watch the video of this entire webinar, including this Q&A session. So be on the lookout for some emails following up from this webinar today. Let's see, what else we got? Here's another one, and maybe you could show them this portal if you can, Patrick. I don't know if you have it set up, but we have a question about how do I download GibbsCAM 13?
How do you download GibbsCAM 13? Let me shut the PowerPoint down for just a minute. I'm going to go to Google Chrome, and I'm going to go to this little link here that says GibbsCAM support. And what we have here is what we call the new GibbsCAM customer self-service area. And as you can see here, here's the link. It's 3dsupport.microsoft-something-portals.com. I'll highlight that for you so you can snapshot that on your screen. And we'll also send this link to you in the email if you'd like it. But it's easy to find in a search on any web browser. And in this 3D system software support, we have all of these different categories right here. We have the knowledge base, we have training videos, we have the interface walkthrough for version 12, the GibbsCAM training schedule, GibbsCAM webinars, and here is the download button for GibbsCAM 13, whether you're using a standalone key version or a network license version. Download server software and the NLO installation guide. There's also a little video here that's what's new in GibbsCAM 13. We also have backwards GibbsCAM 12 support and documentation. The GibbsCAM macros Wikipedia site, V13, all the PDFs that you can load onto your phone or your iPad or to your tablet so that you can have your GibbsCAM manuals wherever you go. And you can look up references to things inside of GibbsCAM. We also have GibbsCAM sample parts, macro samples, and all of this is in the new GibbsCAM 3D Systems software support section, which does not require a username or a login like the old support area used to. You had to type in your username and your password, and we don't have to do that anymore with the support section.
Right. So as Patrick noted, this replaces the old Gibbs Online. So if you have that link saved, you can just forget about that link and save this link. And as Patrick noted, you don't need any credentials, no password, no username. to get in and access this information, all you need to do is just be current on maintenance, and then you can access it all. All right, we got a couple more here. One of them is kind of a real specific question. It says, using volume mill in one of our Fidels, I get an error, arc is too small. Is this a setting within GibbsCAM that he can adjust, or is this
Yes, it is.
a machine setting at the
Yes,
machine?
it is. Let's see if we can force this error. We're going to make another new file. We're going to call this volume mill. Did I spell volume mill right? I did not. Volume mill test, save changes, no. We'll make a quick part here on a 3-axis mill part. 3-axis vertical mill. And let's see if we can force that error so we can fix it. We're going to make this 2 minus 2, 0 minus 2. And let's make a pocket on this part. We'll use a single viewport. A simple pocket is all we need. We'll go to solid modeling. We're going to create a cube, stock dimension. We're going to create a simple pocket shape, 1.5. Let's extrude that shape and subtract it from the model because we want to see this in solids. This one. All right, so now we have a pocket and it does not have any radiuses on the edges. I'm going to get rid of the geometry because we don't need it. I'm going to get rid of the radiuses. Let's see if we can force that alarm, and I can tell you where the alarm is going to come from. We have a tool here. Let's make it a 1/2 inch flat end mill with 1.25 worth of flutes, 3.5 inches long, 6 flutes, length out of holder 1.375. And of course, we want to use we'll say shrink fit for now. And it is a solid carbide end mill. Let's make a volume mill toolpath and see if we can make that error happen. Volume mill. And let's go to technology expert. While we're here, for those of you who do not know anything about volume mill, we went to Mars and we came back with some new toolpaths. Machining has changed a lot in the last 50 years. The way we cut has changed and the way we teach has changed. Excuse me for just a moment. So the way we cut has changed. Let's look at it as if this were a tough part, precipitation hardened, Rockwell C 32. My spindle RPM is 10,000. My max feed rate is 500. My work holding is in the middle of the road. My cutting aggressiveness is in the middle of the road. Volume mill. Our tool diameter, we're going to use a hydraulic chuck, and the tool is coated. From then, GibbsCAM and volume mill have selected all of the technology that you need to cut this part. The RPM, the feed rate, the depth of cut. For cutting and for entry, all we have to do is click apply all, set the bottom of the pocket, click on the solid and press do it. And here comes our toolpath, and we now have a volume mill toolpath. We'll go to machine sim, select no machine, and let's run this part so that you can see, for those of you who have not seen volume mill yet, POV lock is the part. We helix in the center of the part, and once we get to 3 times the diameter of the cutter, it will start to slice outwards. And as you can see, in this particular case, on this hard material, which is Rockwell C32, precipitation hardening 15.5 stainless steel, it is not burying the cutter in the material. It is slicing the material away using 6% of the side of the cutter. Now, all this is leading up to this alarm that we're having is radius too small. And right here, we have minimum toolpath radius. We generally want to set your minimum toolpath radius to just below the radius of the tool, because by changing minimum toolpath radius, it allows us to get into tighter areas. And if we change this number to too small a number, it will say radius is too small. Now on this part, I should have thought forward a little bit better, but if I make this 10 thousandths, it's probably going to say, no, it's giving me a toolpath. But if I had a small confined area, it might give me a
Hey, Patrick, I think how you've answered it is fine. You just told them you got to make sure that the radius of the tool is set, or excuse me, is set smaller than a little bit less than the radius of the tool. The setting should be. So that's the important part.
I use about 25 thousandths less than the radius of the tool.
There you go.
And that should get rid of that alarm for you right there. So volume mill, twice as fast, 4 times better tool line.
Yeah. And for anybody out there that's not using volume mill right now and you rough out and remove any amount of metal, strongly recommended start using the volume mill. Advantages in tool path, advantages in tool life, advantages in cycle time, advantages in machine tool wear and tear. So if you're not using that, you should really take a look at it and give us a call if you have any questions about it. Hey, we're going to wrap this up because we're going over a little bit, but Patrick, I'm going to ask you to do one last thing, and that is, will you call up the CAMCO website?
Absolutely. And I wanted, are you going to talk about CAMCO? I was going to talk about CAMCO.
Yeah.
If you would like to talk about it, that would be just fine.
Yeah. So what we're going to do really is we're just going to talk about the website, because what I want to make sure everybody knows is there was a few questions here where they can get information and where they can download stuff and get access to critical contact information. So the one place that we want to point everybody to is the CAMCO website. By the way, what Patrick has up there now, or just closed, if you haven't joined up for our emails, please do, because we do monthly tech tips. This is how we send out our webinar invitations. You'll also get other information that we pass along that comes from GibbsCAM Corporate. But from the GibbsCAM website, there's several pages there to go through, but the most important one, Patrick, go ahead and click on the support and training page. Well, I'm sorry, Patrick, go back to the home page just for a second. My apologies. One of the things on the home page, and scroll down just a little bit, Patrick, so they can see the events, upcoming events right underneath that right there. So you can always check on our website to see what events are coming up. As you can see, there was a spotlight seminar. There's a monthly spotlight seminar showing, highlighting a particular capability in GibbsCAM. There was some training for GibbsCAM that just was recently completed. And then of course we put this webinar on here. So as we have upcoming events, we'll be posting them right here so that you're aware about it. But now, Patrick, go ahead and go to the support and training page. This is the one I want to make sure everybody accesses, because you can get a lot of information here. So initially it talks about our training. We offer training in multiple different formats, from online training videos to online in person, or we come to you or you come to us and we'll do it in person. And if you keep scrolling down through there, Patrick, you'll see that you have all the contact information for not only our support, which is Jim Green, our support engineer, but also for the GibbsCAM tech support. So between GibbsCAM tech support and our local East Coast based tech support, we offer you 12 hours of tech support. And if you keep scrolling, Patrick, keep going, go ahead. Yeah, you'll see we also have instructions here for getting your post processors modified, how to get machine sim models made. And then towards the bottom here, keep going. Go ahead, Patrick. Well, you'll see the links to the latest tech tips and the latest webinars that we've done, but also this is where you can access that portal for the newest portal that replaces GibbsCAM Online, or Gibbs Online. So the CAMCO website, which is camco-ne.com, is a one-stop place where you can get all the support, contact information you need, training information you need, tech tips, webinars, and access to that portal. So I just wanted to close and wrap up the webinar with pointing to this valuable resource. If you aren't aware of it yet, please make use of it. And it's also a very easy way to get in touch with us at CAMCO. So from there, we will wrap this up. And like I said, apologize, we went a little over, about 10 minutes over our allotted time. But thank you for attending the webinar, and hopefully we'll see you at a future webinar. Thanks.
Thanks, everyone.